Video I explain about the SFD and BMD for cantilever beam. The cantilever beam means one end fixed and other end is free. Okay. The problem is the cantilever beam of span 6 meter carries the point load of 5 kilonewton at free end and another one point load of 4 kilonewton at 2 meter from free end. Draw the SFD and BMD. Here the remaining distance is 6 minus 2, that is 4 meter. The fixed point is A and the free end is B, another one point is C. First calculate the reaction. Here only one reaction because only one support, that is RA. The support is at A, so that reaction is RA. Applying summation of vertical force equal to 0. Upward means put plus sign. Here RA is upward, so put plus sign, and there is 2 point load, one is 4, that is downward, so put minus sign, and another one is downward load, that is 5, so minus 5 equal to 0. RA equal to minus go another side means plus, so plus 4 plus 5 equal to 9 kilonewton, that is plus 9, so acting upwards, positive sign, so acting upwards. Okay, next shear force calculation. Shear force means the algebraic sum of all the vertical forces acting either to the left or right of the section. All the vertical sum of all the vertical force. If A left, first is A point left side, there is no force, so 0. Right means considering the force at that point A, there is only one force RA, that is upward sign. Okay, here we need to discuss about the sign conversion of shear force. If the left side of the section of the beam is higher than the right side section of the beam, is known as positive shear force. This is the section HH. Here left side we need upward force. Left side we need upward force means positive, and right side downward means negative. Sorry, positive. That is also positive. Left side upward positive and right side downward is also positive. Then if the left side of the section of the beam is lower than the right side section of the beam, the section is HH, that is here we need left side force because the portion is lower. Here we need upward force because the portion is higher. Okay, so for negative shear force, for positive shear force, left side upward, and negative shear force left side downward. For right side downward means positive and right side upward means negative. Here take the shear force to the left of the section, so upward sign means positive, upward, okay, plus RA, because to the left upward is positive R is already calculated as 9 kilonewton. Substitute the value 9 kilonewton plus 9. Okay, then another point is C. Taking the shear force at C left equal to C left side. From A to C there is no loads, so C left side only one force is, that is RA. Okay, left means without considering the point load at C, that is here only RA equal to 9 kilonewton. Okay, then C right means considering the point load at C, that is downward, that is 4, so negative. From to either to the left means downward is negative, so left is 9 minus 4 at C is 4, so 9 minus 4, that is 5 kilonewton. Then taking shear force to B left means C to B there is no load, so B left is one is RA, that is upward plus, and another one is downward 4, that is minus 4, that is 9 minus 4, here also 5 kilonewton. B right means considering the point load at B, that is downward 5, so downward means 5, left is 5 minus 5, that is 0. Then for draw the SFD, first we need to draw the baseline. In the baseline the shear force is always 0. Above the baseline shear force is positive, and below the baseline shear force is negative. Mark the points A, C and B. Okay, first A left shear force is 0, so mark at the baseline. A right is plus 9 kilonewton, plus means mark above the baseline at A, that is 9 kilonewton. Then C left is also 9 kilonewton, so above the point C, that is 9 kilonewton. Then C right is 5 kilonewton, this is also the 5 kilonewton is above the point C, that is 5 kilonewton. Then B left is 5 kilonewton, that is also above the point B, that is 5 kilonewton. And B right is 0, so mark at reference line. Then joining A left to A right, then A right to C left to C right to B left to B right. Here all of the value is positive, so put positive sign. Okay, this is the SFD. Then bending moment calculation. Okay, bending moment means the algebraic sum of all the moment of forces acting either to the left or right of the section. Shear force means algebraic sum of all the vertical forces. Bending moment means algebraic sum of the moment of forces. Moment of forces means force into distance. So first calculate the bending moment at B, that is free end. That free end only one load, that is 5 kilonewton. From 5 to B there is no distance, so distance is 0, so 5 into load into distance 0, so equal to 0. Then bending moment at C right side only one load, that is 5. From 5 to C the distance is 2, so 5 into 2. Okay, here we need to discuss about the sign convention of bending moment. If the beam tends to bend in the curvature of convexity upward, means that is known as negative bending moment or hogging bending moment. Here we make to be must state means this is hogging bending moment negative. To make the beam straight means here we need anti-clockwise direction left side, and right side we need clockwise moment. So left side anti-clockwise and right side clockwise means negative moment or hogging moment. Okay, another one moment is sagging or positive. The beam tends to bend in the curvature of concavity upward means that is known as positive bending moment or sagging bending moment. Here to make the beam straight, left side we need clockwise moment, right side we need anti-clockwise moment. So from left anti-clockwise negative, clockwise positive. To the right means clockwise negative and anti-clockwise positive. Here to the right of the section. So right of the section means clockwise negative and anti-clockwise positive. Anti-clockwise positive, clockwise negative, anti-clockwise positive. So here right of the section 5 into 2. So we need to find the direction. This is 5 into 2. This is clockwise directions. So to the right clockwise, so that is negative sign. That is minus 5 into 2, that is 10 kilonewton meter. Unit of bending moment is kilonewton meter. Then bending moment at A equal to A right side. There are two forces. One is 5. From 5 to A distance is 6. This is clockwise direction, so put negative. Minus 5 into 6. Another one moment load, that is 4. 4 into distance is 4. Here also clockwise direction, so minus 4 into 4. Okay, minus 5 into 6 is minus 30. Then minus 4 into 4 means minus 16. Then minus 46 kilonewton meter. Okay, then we need to draw the bending moment diagram. First draw the baseline. At baseline always BM is 0. Above the baseline is positive, below the baseline is negative. And mark the point. At B bending moment is 0. So this is A and this is C. So mark at reference line at B. Then C bending moment is minus 10. Minus means mark below the reference line at C. That is minus 10 kilonewton meter. Then A is minus 46 kilonewton meter. This is also minus, so mark below the reference at or line at A, that is 46 kilonewton meter. Take any section H which is at the distance of small h from B. Bending moment at this section is Mh equal to its right side only one load, that is 5 into distance is h, so minus 5 into h. Okay, we know that equation of straight line is y equal to mh plus c. Here mh equal to bending moment at h also minus 5h, so satisfy the condition of straight line. So connect the point as straight line. First B to C, then C to A. Here satisfy the condition of straight line, so connect the point as straight line. So this all in bending moment all of the sign is negative, so put negative sign. Here in BMD the bending moment at free end is 0 and fixed end is maximum. So for cantilever beam the bending moment at free end is 0 and fixed end it is maximum. So we need more reinforcement at fixed end. Thank you.